Hello everyone, let us start our class. And still we have been studying a reflection of light at curved surfaces. This is end of the chapter, and some miscellaneous concepts have to be covered in this class. And in previous classes we discussed rules for ray diagrams, and we drawn ray diagrams by applying possible rules, and we we have written nature of each case of concave and convex mirrors, and we solved some problems based on mirror formula and magnification formula by applying sign conventions. And today we are going to write magnification values for each case of concave and convex mirrors. Magnification values. Magnification values. Let us see first case for concave mirror. First case for concave mirror, already we drawn all ray diagrams and we have written nature for each case. And when object, in first case, when object placed at infinity, object at infinity, object at infinity. Let us draw ray diagram. This is concave mirror, curved inward reflecting surface. It has a curved inward reflecting surface, and it is converging mirror. Okay, converging mirror. Principal axis, which is passes center of the mirror, and here it is center of curvature, and it is focus and pole, which are lies on the principal axis. Object at infinity. When object placed at infinity, rays, incident rays coming from the object which is placed at infinity, incident rays always towards the mirror, already I told you, and incident rays always towards the mirror. And one more incident ray, and below the principal axis one more incident ray. In one and only in one case, when object placed at infinity, you can take object above the principal axis and below the principal axis. That's why incident rays coming from the object above the principal axis and below the principal axis. Okay, incident rays strikes the mirror, reflected back, and then reflected rays passes through the focus, and it is passes through like this. It passes through like this, passes through focus, and this incident ray, this reflected ray passes through the focus. Passes through the focus. Where the reflected rays intersect, their image can be formed. all reflected rays all reflected rays can intersect at focus. At this point, image can be formed. So now we have to write a nature of the image. All these things we discussed in previous classes. Image at infinity. Focus. Image at focus. This is the first point. Then, what is the size of the image? One thing we have to remember, when we are going to measure the size of the image, it always measure. It should be measured. It should be measured from the principal axis. But in this situation, image can be formed on the principal axis. Image can be formed on the principal axis, but image at focus only. So image size is highly diminished. Highly diminished. Highly diminished. Now, image is real. Image is real. We know already. All real images are inverted. Inverted. All real images are inverted. Once we write the nature of the image, then we can write the magnification value for this case. How to write the magnification value? How to write the magnification value? Just observe carefully. Make sure we have to observe two things. One is whether it is a real or virtual image. Whether it is a real or virtual image, one thing, and one more thing, whether it is a magnified or diminished image. Magnified or diminished image. These two things leads the magnification value. So magnification M. So first of all, magnification is nothing but how image size varying or image size is changing compared to the object size. That is magnification. How changing image size compared to the object size. That is magnification. It is denoted by M. M is magnification, and we know for this case we got highly diminished image. Highly diminished means less than, and it is a real image. For real images, magnification. For real images, magnification is negative. For virtual images, magnification is a positive. So it is real images. That's why negative, we consider negative and 1. This is magnification value for this case. Clear? Let us draw second case. Second case. When object placed beyond center of curvature. Object beyond C, center of curvature. Let me draw ray diagram. This is concave mirror, curved inward reflecting surface, principal axis which is passes to the center of the mirror, and the center of curvature, focus and pole lies on the principal axis, and our object is placed beyond the center of curvature. Now we have to apply the possible rules. This is incident ray, which is always towards the mirror and reflected, strike the mirror and reflected back and passes through the focus. You know. And one more rule, the incident ray which is coming from the object and towards the mirror and strikes the mirror, it gets reflected back and it after reflection it becomes principal axis. Principal axis. So where the reflected rays are intersect, their image can be formed. So it is reflected rays. These are reflected rays. So our image is formed in between C and F. Now we have to write the nature of the image. Image in between center of curvature and focus. Right? Now the size of the image. Now we have to write the size of the image. Size of the image should be measured from the principal axis. From here to here, the size of the image. You can observe, compare the size of the image. Compare the size of the image with size of the object. Definitely, it is little bit diminished, slightly diminished compared to the object size. So it is diminished image. Diminished image. And it is real. Image is a real image. Image is real. We know already all real images are inverted. Now we can write the magnification. It is denoted by M, and already I told you, make sure we remember two things, or we observe two things. One is the size of the image. One more thing, whether it is real or virtual images. Right? For real images, magnification is negative. For virtual images, magnification is positive. So magnification M, and it is diminished image. So M less than, and it is real image. So we consider -1. This is magnification value for this case. When object beyond center of curvature, our magnification value is M less than -1. Clear? Next, let us see third case for concave mirror. We completed when object placed at infinity, and we completed when object placed beyond the center of curvature. And in this case, when object placed at center of curvature, object at center of curvature C. Let me draw the ray diagram. Concave mirror, curved inward, reflecting surface, object lines are taken outside. Principal axis which passes through the center of the mirror, and center of curvature and focus and pole which are lies on the principal axis. And in this situation, object at center of curvature, our object is placed here, and now we have to apply the possible rules. First rule is valid. Incident ray which is towards the mirror and strikes the mirror after reflection, the reflected ray passes to the focus. We know very well. And second rule is also applicable. Passes through the focus, strikes the mirror after reflection, the reflected ray. After reflection, the reflected ray will become principal axis. Where the reflected rays can intersect, where the reflected rays or intersect, their image can be formed. These two reflected rays intersect these two reflected rays intersect here. Here image can be formed out. Now measure the image size from the principal axis. So it will be same size of the object size. Now write the nature of the image. First point, where is the image location? First, image can be formed exactly at center of curvature only. Image at C only. Object at C and image is also at C. Now size of the image. Size of the image. Size of the image equal to the size of the object. So same size of the same size of the object size. Now image is a real and all real images are inverted. Now we have to observe two things. One is size of the image and one more thing, whether it is real or virtual image. For real images, magnification is negative. For virtual images, magnification is positive. So magnification M and the size of the image, same size of the object. Then we can write equal. Magnification is equal to, and real. For real images, magnification is negative. M equal to -1. So magnification M equal to -1 for when object placed at center of curvature. Clear? Next, fourth case. In this case, object should be placed in between C and F. Object between center of curvature and focus. Center of curvature and focus. Let me draw a ray diagram. And the center of curvature, focus and pole. Our object placed in between center of curvature and focus. This is our object. We can use first rule, and it is parallel to the principal axis, strikes the mirror, after reflection passes through the focus. Clear? And we can use second rule also. Second rule, passes through the focus and strikes the mirror, after reflection it becomes principal axis. These two reflected rays can intersect here, this point exactly beyond center of curvature. Now we measure the size of the image. Definitely it is bigger than object size. Clear? And our first point is image can be formed beyond center of curvature. Beyond C. Our image can be formed beyond C. And the next point, size of the image definitely magnified compared to the object size. Right? Suppose our object A and B, our image A dash and B dash, inverted. That is real images. That's why it is inverted. A dash and B dash. So size of the image is magnified. Magnified or enlarged. Enlarged image. And our image is real, and all real images are inverted. Inverted. Now we can write the magnification value for this case. We have to observe two things. One is size of the image, and one more thing, whether it is a real image or virtual image. It is real image. Now we can write the magnification value for this case. Magnification M, and it is magnified image. Magnified image. So image size is bigger than the object size. M greater than, and it is real image, For real images, magnification is negative, so we write minus and 1. So our magnification value m greater than minus 1 for this case when object between center of curvature and focus.